All right. Hey, pre-calculus. So we are now on the third video. I'm starting at question 15, 1-5, okay? So question 15 says factor completely. So in order to factor trinomials like this, that's functions, that's three terms there, we need to use our X method. So let's go ahead and do it. All right. So remember what our X method tells us to do. It says A times C, that's A is our term right here. In this case, it's 1, times our C term, in this case, negative 28. And then B for our bottom term, in that case, it's negative 3. And so what we're looking for when we're factoring this is we are looking for what two numbers multiply to 28 and add to negative 3. So the two numbers that add to negative 3 multiply negative 28, well, in that case, it's going to be negative 7 and positive 4. So negative 7 times 4, that's negative 28. Negative 7 plus 4, that's negative 3. So there's our final answer. Let's go ahead and write it. X minus 7 times x plus 4. That's our final answer. We can leave that alone. That is our answer for 15. Let's look at question 16. So question 16 is different, and the reason I know it's different from 15 is that this is just two terms. And so when we see two terms, we know that we need a little bit of a different approach here. And so in this case, I want to look for the GCF, the greatest common factor between these two terms. And so I notice between my 4 and my 16, the GCF of those two coefficients is 4. And between x squared and x to the first, my greatest common factor is x to the first power. And so what I'm going to do is I'm going to factor out or divide out by 4x. And if I divide each of these terms by 4x, let's see what we get left. So 4x squared divided by 4x, well, that just leaves me with x. And then 16x divided by 4x, that leaves me with just positive 4. And that's it. We're all done for question 16. Let's move on to question 17 here. All right, question 17 is another factoring question, but this time it's a little bit more challenging. So, the reason it's a little bit more challenging for question 17 is that A, our first value, is not equal to 1. In this case, it's equal to 2. So anytime you see A not being equal to 1, let's try to find a greatest common factor. Let's see if there's anything we can factor out of all three terms to make our factoring process a little bit easier. And in this case, I see one right away. 2, 22, 48. Well, they all have a 2 as a multiple. So let's go ahead and factor out a 2. Okay, I'm left with 2 times k squared minus 11k plus 24. All right, and so now what I'm going to do is I'm going to factor what I have here in the parentheses. And so again, our factoring using our X method, A times C, now it's 1 times 24. Our B term is negative 11. And so I'm looking for two numbers that multiply to 24 and add to negative 11. In this case, I know those two numbers are going to be, let's see, negative 8 and negative 3. Yeah, that'll work. So negative 8 and negative 3, and that will help us write our final answer. All right, cool. There is our final answer. I've done everything I can. I've factored everything. We're all good. We're all done. Let's take a look at question number 18 here. What is the parent function graphed below? So again, parent functions, in this case, this is the graph of x squared. And the parent functions are just something that y'all should memorize for the test. So x squared, absolute value of x, x to the third, square root of x. Those are really the four most common ones that come up a lot. So Our parent function is just x squared here. All right, question 19 here. All right, it says evaluate the function for f of -8. And so essentially what this is telling us to do is this piece of information is telling me that x equals -8. Okay, we wrote it in function notation, but that's what it's telling you. It's saying x equals -8. And what we're going to do is we're going to take that information and substitute it in for x. And we're going to solve. And that's it. So watch me do this. I've got 3x plus 9. As I just said 10 seconds ago, we know that from the question they want us to evaluate when x equals -8. So all we're going to do is substitute in 3 times -8 plus 9. And we can type this in. 3 times -8, is that -24? And so -24 plus 9. Let's go ahead and think about what that will be. So -24 plus 9 gives us a final answer of -15. Perfect. All right, we got it for number 19. For question 20, essentially the same question. They're telling us that we're asking for f of -3. So that means x equals -3. Okay, easy enough. We're going to take that -3 and substitute it in for x. Let's be careful to use parentheses and we'll be good. All right, -3 squared plus 8 times -3 plus 20. And we can go ahead and simplify this. Now we're going to have calculators on your exam, so you could type this in. The only mistake that tends to come up is people forget to do parentheses. And so if you type this whole mess in, let's see what we get. -3 squared, that gives us 9, minus 24 plus 20. Looks like our final answer here should be 5. Okay, cool. And that's how you do question 20. Let's keep it moving. All right, question 21 says find the y-intercept of the function. All right, so anytime you want to find the y-intercept, remember the y-intercept is where x equals 0. Okay, so the y-intercept is where x equals 0. Okay, and if you want to look at an example of a graph, wherever the y-intercept happens, that's when x equals 0. And so that's really the easiest way to solve this. We are going to go ahead and substitute in 0 for x, and we'll solve. Okay, so I've replaced x with 0. So 2 times 0 squared, well, all of that just gives me 0. Minus 44 times 0, well, all that gives me 0, plus 48. So our final answer here is just 48. You're done. So in order to find the y-intercept, you just got to know that's when x equals 0. Let's move on. This next question here says find the relative minimum. There's actually 2 relative minimums. So remember, the word relative means it's a change in direction. It's an area of the graph where it's a low point relative to other features of the graph right around it, but it's not necessarily the lowest point on the whole graph. And so in our case, that occurs at 2 points. It occurs right here when x equals -4, and a second relative minimum, a low point, you'll often see it as a valley like this, occurs here when x equals +6. So those are the 2 answers I'm looking for here. They occur at x equals -4 and x equals 6. That's what our answer should be there. Let's keep it moving. All right, cool. Let's take a look at question 23. It says determine the interval on which the graph is decreasing. Okay, the interval with which the graph is decreasing. Remember, y'all, when I talk about interval, I'm talking about the domain. I'm talking about the domain of my function here, okay? And I'm looking for where it's decreasing. So as we read our graphs from left to right, we are decreasing whenever we are moving down. So as I move left to right, this is an area of decrease, this is an area of decrease, and this is an area of decrease. So let me highlight those areas for you. All right, cool. I've highlighted the 3 areas of graph where those are intervals of decrease, where we're moving down as I move left to right. And so I'm going to go ahead and write the x values for which those values occur. So starting with our first piece, we're going to get negative infinity up to -7. And then we're going to write a u for union. And then the next piece of our graph here is from -4 to 1. Again, y'all, as I go through this, I'm looking at the x values here, not the y values. I'm looking at the x values. And then one more union. This last piece goes from an x value of 4 to an x value of positive infinity. Okay, so negative infinity to -7, -4 to 1, and then 4 to infinity. So that's our final answer for question 23 here. Okay, awesome. There's our final answer. Let's go ahead and erase. All right. Question 24 is similar to some questions we've done before here. It says evaluate the function for f of -8. Y'all know the drill here. We're going to substitute -8 in for x. Okay, so I've replaced x with -8. Pretty simple. Again, y'all will have calculators, so y'all can type that in. Again, be careful to use your parentheses there, and y'all are going to be all good. So if we go ahead and substitute that in, let's see, what are we going to get? We're going to get 3 times 64 plus 16. Looks like our final answer should be 208. All right, cool. There's our final answer, 208. Let's keep it going. All right, I'm on question 25 here. Determine if the following graph represents a function. So for question 25, this is using the vertical line test. And the vertical line test tells us that if at any point we can draw a vertical line and it goes through our function at more than one point, it fails the vertical line test. It's not a function. And so in the case of this graph, this is a function. So I'm going to say yes, function. And our reasoning is because it passes the vertical line test. I can draw a vertical line, and at any point it only goes through one point. That's question 25. Question 26 says solve for n. This will be the last question I do, and then I'll make a new video. So solve for n. -2 times -8n minus 8 equals 80. So our first step is going to be to distribute that -2 term to both terms. So that means multiply. So let's write below. So I've got 16n plus 16 equals 80. So I've distributed, great first step. Now I need to go ahead and solve for n. The way I do that is I get my integers on one side and my variable n on the other. So the opposite of adding 16, well, that's subtracting 16. I'll take that from both sides, and I'm left with 16n equals 64. As my final step, 16n, that's saying 16 times n. So the opposite of multiplying by 16 is dividing. And I'm left with 64 divided by 16. My final answer is going to be 4. All right, let's cut it off there.